So in this video we are going to see the special value of trigonometrical function, which is 60 degree. It is called pi by 3. So far we have checked for 90, 45, 30 degrees, but we are going to see here the 60 degree. So let's check. So we are going to start up with the unit circle as we did for all the other angles. So this is a unit circle. The radius is 1, x and y axis. So here the coordinate is 0, 1. Here the coordinate is 1, 0. So here the acute angle has to be 60 degrees. So we will draw an angle 60 degree here. This is point, we'll name it as A, and it's going to touch the circle at point B. And here we are going to do one thing. We are going to draw at point B, we draw an angle ABC with measure of 60 degree. So we are going to draw an angle ABC. This angle is 60 degree. So this is 60 degree. Okay, we know that the inner angle, total of the inner angle of a triangle is 180 degree. So this, let's say this point is C. So the C angle will be, so the angle ACB will be 180 degree minus 60 plus 60. So which is going to be also 60. So this angle is also 60. So basically, so we have a construction in the B point that we made an angle of 60 degree. That's what we did. This is a construction at B. Construction we did at B to prove it. To prove the pi by 6 value. So actually, as per the construction, ABC, triangle ABC is a equilateral triangle, right? So equilateral triangle. So for the equilateral triangle, all the angles are equal, inner angles are equal, and also the sides are, each side of the equilateral triangle is same length. So here we know AB is radius, right? AB is radius, so AB is going to be 1. So AC is also going to be 1, right? So we are going to bisect. Bisect the angle B. Bisect mean 60 degree. The B angle is 60 degrees. So which we are going to make it into two part. We are going to draw a bisector from B to AC. So bisector is perpendicular to the opposite side. So this is 90 degree. So here this angle is 30. This angle is 30. So it's a bisector. We will call this as the bisector BD. So we draw a bisector angle B, which is BD, right? So let's say this AD is X. Let's make it, let's make the AD as X. So AD is X mean DC also X, right? Because BD is a bisector of AC. It's going to divide the AC into two same portion. So AD, DC both are X. So and AB is 1, the unit circle. So we are going to use, so let's say the BD as Y for a calculation. So I'm going to take the triangle ABD. ABD. It's a right angle triangle. So we're going to use the Pythagorean theorem. Pythagorean theorem for the particular right angle triangle, which is going to be hypotenuse squared, right? Hypotenuse, this is hypotenuse. So 1 squared is equal to all the other sides squared plus, so x squared plus y squared. Okay, so but we know this, we can say this AC is 1. This AC is 1 because it is all are the radius of the circle. So AC, AB, everything is 1. So AC is equal to 1. So X is a bisector of AC, which is half. So which I am going to substitute here. Substitute 1. Substitute in equation 1. So 1 is equal to half squared plus y squared. So 1 minus 1/4 is equal to y squared. Y is equal to y squared is equal to 3/4. Y is equal to √3/2. Plus or minus, but minus not suitable because y is a length, so it should be greater than 0. So y is going to be plus √3/2. So let's substitute this value in the equation. No need, so we already know the x, right? So x is half. So y is not known, x is known. So what is y, what is x here? So the point, so the value of special angle 60 of a trigonometrical ratio will be here. The the trigonometrical ratio for this point, the coordinate will be cos t comma sin theta. Cos t comma sin t, cos 60 here, cos 60 degree comma sin 60 degree. So that will be the coordinates. So cos 60 is cos x is cos 60, right? X is going to be cos 60, y is going to be sin 60. It's obvious. So x cos 60 is equal to half. If you want to know more about this, you can check the previous video, session 2 of this series. Then I have explained how we derive this cos and sin coordinates of the particular point of the particular angle which we are calculating. So sin 60 is going to be √3/2. So we have derived it. So we'll recap all the angle and one shot. Angle, cosine, sine. You can memorize it. It's possible. It will be really fine. pi by 2 or 90. Then we check for pi by 4, 45 degree, and we have calculated for 30 degree, pi by 6, and then we have calculated for pi by 3, 60 degree. It will be, for this one, cosine 90 is 0, sine 90 is 1. This both are for 45 degree, both are same value, 1 over root 2. Very easy to remember. Then cos 30 is going to be cos 30 is root 3 by 2, and this is half, and this will be other way around of this, half and root 3 by 2. It's a simple trick, so you have to remember this chart and it will be easy for you. So first let's try to draw all the common angles in first quadrant of the unit circle. So first quadrant means, I have already told you the first one. I mean, this unit circle means this is the first quadrant, second, third, fourth. So I'm going to draw all the angles and the value here, right? First quadrant. So first we have cos 0 and sine 0. The coordinates in every point will be cos t comma sine t. T will be varying. Here in this point, in this horizontal point, it's going to be 1 comma 0. So what is mean by this is cos 0, t is 0 here. In this angle, t is 0 because there is no angle, it is horizontal line, just a horizontal line. So in this angle, t is 0. So for cos 0 is 1, sine 0 is 0. So you can see from this is obvious because we don't have to derive it. It is obvious from a quadrant, first quadrant of the circle. So then we will move on to the 30 degree. So 30 degree, cos 30 and sine 30. This is going to be, this point is going to be root 3 by 2 comma half. Means the x value is root 3 by 2. So the y value is going to be half. Then 60 degree. 60 degree will be half comma root 3 by 2, other way around. So this x value is half, and y value is going to be root 3 by 2. And if you draw for 40, this is 60 degree, mark it. And then if you draw for 45 degree, it's going to be the same value for x and y. It's going to be 1 over root 2 comma 1 over root 2. Cos 45 is 1 over root 2, sine 45 is 1 over root 2. 1 over root 2. And then the 90 degree, cos 90 and sine 90 is obvious because this point we know this is a vertical point. This is 0 comma 1. So cos 0 is 0, sine 0 is, cos 90 is 0, sine 90 is 1. So this is the obvious points which we can get from. So the next part will be finding, it's going to be very interesting part, finding reference angle. So far we have learned the sine and cosine value of angles which is in the first quadrant of a circle. like we have checked for angles which is 0 to 90 degree. So it is 0, 30, 45, 60 and 90 degree. We know all these values now. But what about if there is any angle which comes in the second, third, fourth? So what will be the values of sine and cosine for this kind of angles? So let's say so for logical thinking, by logical thinking we can derive some of the some of the values. For this is x, this is y, this is a unit circle. So let's say there is an angle t here and the coordinates is x comma y. So x value denotes cos t, y value denotes sin t. So what about the if you draw in the second quadrant, if you draw a symmetric way of angle here, like this is t, means let's say this is t, so let's say this is alpha. So we are going to find out what is sine alpha. If you draw in a symmetric way, so actually this is not symmetric, it's not look like symmetric but symmetric. So the value here is in this coordinate, the value here is going to be the y value is going to be the same. So and x value is going to be some minus x, right? So minus x comma the same y. So sin t is sin alpha. So we can say sin alpha is equal to sin t, because here the sin value, I mean the y value is same. Since they had drawn it as symmetric, this is also y, this is also y. So this is sin t, this is sin alpha, and sin alpha here is sin t. Sin alpha is called the reference angle. Alpha is called the reference angle. We can write alpha as, this is the horizontal line, right? So 180 minus t, 180 minus t. We can write alpha in terms of t. So sin alpha is going to be sin t, the same value as sin t, because it's in the symmetric way. And what about cos alpha? Cos alpha, here the cos alpha is, it is this y, I mean same cos alpha. Here the cos alpha is minus x, right? Minus x. So here the x is cos t, so the minus x is going to be minus cos t. This is for the second quadrant. If we reference angle in the second quadrant, so means reference angle means what is reference? If you take any angle greater than 90 degree, which is in the second quadrant of the circle, so we can relate with the acute angle, relate value with the acute angle in the first quadrant of the circle. So you can memorize this, sin alpha is 180 minus t. So it is means sin 180 minus t is sin t. That is what we wanted to prove. So if you have like sin 30 degree, so let's say t is 30 here, So you can find out 180 minus 30 also the same value. So sine 180 minus 30 is sine 150 is going to be the same value as sine 30. That is what we are going to find out here. This is the application of this. So if sine 30, some acute angle, if you know the value of sine 30, we know because we have the chart. So what about 150? You don't have to calculate it again and again by drawing this and that. So you can just use the sine 30 value. Since we know the reference angle sine value is the same, it is 180 minus 30. So this is the case for the second quadrant of the circle. Let's go for the fourth quadrant. So the same way I am going to draw a symmetric. So let's say this is T, an acute angle. So you're going to draw a beta. This is, so you have to, beta is calculated from this horizontal point to this fourth quadrant. So this is beta. This is some angle beta. We have to find out what is the sine value, cos value of this beta. So how to get it? You don't have to calculate again and again. So this is T, means this is also T. It is like a symmetric. So B is a reference angle of T. So you can say this whole circle is 360 degree. So if you deduct T from that, you will get beta. So beta is 360 degree minus T. Okay. And so what about this is x comma y, let's say this coordinate. So what about this? What is this coordinate will be? The x value is not going to change. It's the same value, right? So x. But the y value is going to be, this is y. So this is minus y. It's logic. It's minus y. So the cos value, you can see this is a cos value, cos t. Cos value, this is cos beta. Why cos beta? This is the angle. For this point, this is the angle. So cos value is not changing. So cos t is cos beta. So what is cos t is cos 360 minus t. So what we are going to prove here is cos t and cos 360 minus t also same value. And what about sine value? Sine t is going to be, this is sine t, this y is sine t. Sine t is going to be minus sine t, minus sine beta, minus sine beta. So sine t is going to be, sine t is y. So sine beta is going to be, or other way around, minus sine t. Sine beta is going to be minus of sine t. Right? So means sine 360 minus t, beta is 360 minus t, is going to be minus sine t. So we have just derived all these things from second and fourth quadrant of this unit circle, but let's make it as a whole summary. So if it's a quadrant 1, some acute angle T, this is a quadrant 1. So the reference angle is the acute angle T itself. T dash is a reference angle, right? Reference angle T dash, we'll call it as reference angle. The acute angle T itself, because there is no other thing, it's just T as it is. If there is a quadrant 2 Q2, if this is the T dash, if this is the T dash, so the T dash is going to be 180 minus T. I know this looks a little bit hard since we are studying everything in theory, but let's move on to an example. Let's see an example and everything will be clear out. Example. So we are going to find out using reference angle. Using reference angle, find the exact value of cos 150 degree, comma, sin 150 degree.